In section 1.9, we're going to discuss absolute value equations and inequalities. Now, I'm going to forewarn you, this is not the easiest thing. This takes a little bit of studying and a little bit of thought process behind all of this. It can get a little confusing, so please bring any questions that you have tomorrow in class, and I will gladly answer them. So let's start off under the Solve It section. What I want to do is just kind of like discuss what we're doing, because that's the most important part. So, absolute value equations. What I want you to do is write down this. The absolute value of x equals 3. Now let's first review absolute value. Absolute value represents the distance from 0 on a number line. So if you had, for example, the absolute value of 3, that is asking you, how many units away from 0 is 3? Well, it'd be 3 units. The same goes with a negative number. If you want to take the absolute value of negative 3, that is asking you how many units away from 0 is negative 3, which would also be 3. The absolute value of any number will always give you the positive value of that number. That is a key concept. Always give you a positive number. So in this problem, let's just use our reasoning skills. The absolute value of what number, which in this case is x, is equal to 3? Well, it's going to be either 3 or negative 3, which on a number line would be represented by a dot on negative 3 and a dot on positive 3. Now, if you're going to an inequality, let's say we have the absolute value of x is greater than 3. Think about it. The absolute value of what numbers would be greater than 3 units from 0? So maybe it would help to draw a graph first. We're going to draw our negative 3 and 3. Now, would 3 work? If you plugged in 3, the absolute value of 3 is 3. Is that bigger than itself? No. Is negative 3, the absolute value of negative 3, which is also 3, is that bigger than itself? No. So we would have open circles on negative 3 and 3. Now in this problem, think about numbers that are going to get farther away than 3 units from 0. So if you plugged in, think of a number that would work. What would work here? Would 4 work? The absolute value of 4 is greater than 3. Absolutely. Would 7 work? 9, 10. Any number bigger than 3 plugged in here, the absolute value of that would be bigger than 3. So we know the shaded region is going to go to the right. But what about like negative 5? Now negative 5 in itself is not greater than 3. But what's the absolute value of negative 5? It's positive 5. And 5 is greater than 3, which means the regions to the left of negative 3 also work. Now let's think about this. This negative 3 is 3 units from 0. Positive 3 is 3 units from 0. This is saying all distances bigger than 3 units away from 0. Therefore, we have to go outward. This is outward. If you have a greater than, you're going to be shading outward. Now, what do these regions mean? If you wrote an inequality for just this one, let's say, we would write x is greater than 3. This one right here, that would be x is less than negative 3. You just wrote your inequality, and we'll get to this in a second. This is actually going to be an OR problem because you're shading outward. You cannot have overlapping regions that go opposite directions. The last thing we're going to go over here is the absolute value of x is less than, let's say, or equal to 3. Now in this problem, it's exactly the same, except we want to know distances that are less than or equal to 3 units from 0. So we still are going to have 3 and negative 3. Because 3 and negative 3 both would work here because there's an equal to, we're going to have closed dots. Now I want to know all of the values of x, the absolute value of that, all the distances that are less or equal to 3 units away from 0. Well, we have the equal to. Here it is right here. We did it over here. They're closed dots. Distances that are less than 3 units. Well, if you started plugging in numbers, you'd realize you'd have this, which would be represented by x is less than or equal to 3, and, that's important, and, because this is a conjunction, x is greater than or equal to negative 3. So this is the prelude. This is kind of like how we're starting off this lesson. So if we're looking at the gray box under essential understanding, it says you can solve absolute value equations and inequalities by first isolating, underline that, you must isolate the absolute value expression. That means the only thing that should be on one side of the equation is the absolute value, not the x or the y, the absolute value. Absolute value must be by itself. Then you have to write a pair of linear inequations or inequalities. So let's do an example. I know there's a got it problem. We're not going to do that yet. Write an example to the left, and this is what I want you to write. All right, so we have two examples. Example 1, the absolute value of x plus 4 equals 4. The absolute value is already isolated by itself. So now you're going to write two separate equations. The absolute value, let's pretend the x plus 1 wasn't even there. The absolute value of what would equal 4? Well, it'd be 4 or negative 4. So that means x plus 1 has to equal either 4 or negative 4. All you do, this is it, all you do is take what's inside the absolute value and set it equal to both the positive and negative value of the number after it. So we just take x plus 1, set it equal to 4, and then set it equal to negative 4. Solve both equations. Subtract 1, you get x equals 3. Subtract 1, you get x equals negative 5. That's it. Now if you graphed them, I'm going to make a really rough graph here. If you graph them, you just put a dot on negative 5 and a dot on 3, and you're completely done. The next example, what two equations would you write for the absolute value of 2x minus 1 equals 7? Well, you would have 2x minus 1 equals positive 7, and 2x minus 1 equals negative 7. So here we're going to add 1. We're going to get 2x equals 8. Divide by 2, x equals 4. Over here we're going to add 1. 2x equals negative 6. Divide by 2, x equals negative 3. So my two solutions will be negative 3 and positive 4. So now let's look at the got it. The got it says this. The got it says the absolute value of n and then minus 5 equals negative 2. This is not an isolation of the absolute value. The absolute value is not by itself. You must get the absolute value by itself. So we're going to add 5 to both sides. Then we're going to get the absolute value of n equals 3. Now it's by itself. And now you can write your two equations, n equals positive 3, n equals negative 3. And the graph, which I'm not going to do because it's easy, you're going to draw your graph, put a dot at positive 3 and a dot at negative 3. On page 81, we're going to do practice A problem 2. Here we go. Negative 3 times the absolute value of m is equal to negative 9. The absolute value of m is not by itself at all. So now I have to divide by negative 3. I'm going to get the absolute value of m equals positive 3. And once again, you're going to get m equals 3, m equals negative 3 as your answer. Now there's one thing that I noticed your textbook doesn't really go over well, and that's this. The absolute value of something equals a negative value. What this is saying is that you have the absolute value of something equals a negative. Can you ever take the absolute value of some number to give you a negative number, whatever that number is? You cannot do this. If the absolute value is already isolated by itself, you cannot do it. There is no solution. It's empty set. So you can do empty set, or you can write no solution. Either one works. So if you want to write empty set, or if you want to write there is no solution, that is completely acceptable. Let's look at the got it problem on the bottom of page 81. The problem says another friend's distance d from you in feet after t seconds is given by the equation d equals the absolute value of 80 minus 5t. What does the 80 in the equation represent? What does the 5 in the equation represent? At what time is she 60 feet from you? Now the problem that you need to know, which it doesn't tell you, is that your friend is skating towards you and then passes by you. So here's what the equation means. Starting from 80 feet away, your friend skates towards you and then passes by you. She skates as a constant rate of 5 feet per second. Her distance d from you is given by the equation d equals the absolute value of 80 minus 5t. At what time or times is she 60 feet from you? So 60 feet represents the distance that she's going to be away from you. So your equation is going to be this. The absolute value of 80 minus 5t equals 60. So at any time she can be 60 feet from you, but it can be 60 from the left, 60 from the right, we don't know. Now the 80 feet, what does the 80 in the equation represents? The 80 represents your friend's starting distance from you. So they are starting 80 feet from you. The 5 represents your friend's constant speed, which means the 5 means that she's going 5 feet per second. Now if you solve this, we want to know at what time is she going to be 60 feet from you on both sides. So solve this yourself. If you subtracted 80 on both sides and then divided by -5, you would get the two answers of 4 seconds and 28 seconds. So the question asks, at what times is she 60 feet from you? At 4 seconds when she's coming at you, and 28 seconds when she passes the other way. Our two equations would be the 80 minus 5t equals positive 60 and negative 60. Now look at the got it problem after problem 3 on page 82. It said the absolute value of 3x minus 6 and then minus 5 equals negative 7. The absolute value is not isolated by itself. So we're going to add 5. Instantly you know you're going to get the absolute value of 3x minus 6 equals negative 2. What two equations would you get from that? Wait a minute. Are you going to get two equations? Be careful. The absolute value is equal to a negative. Can't do it. Empty set, no solution. Don't ever forget that. It is very easy to forget something like that. One last thing, and I'm not gonna finish the problem, but I want to write one thing. Let's say we have 2 times the absolute value of 2x plus 6 minus 3 equals 7. If you had a problem like this and you wanted to isolate the absolute value, you would first have to add the 3, because it's like getting rid of a minus 3. You'd then get 2 times the absolute value of 2x plus 6 equals 10. Divide both sides by 2, because the opposite of timesing by 2, by the way, one thing I did not say, which is a common mistake, is distributing. These are not parentheses. These are not grouping symbols by any means. You cannot distribute ever into an absolute value. You cannot distribute at all. So back to dividing by 2, you're going to get the absolute value of 2x plus 6 equals 5. You then would write your two separate equations. 2x plus 6 equals negative 5. 2x plus 6 equals 5. And 2x plus 6 equals negative 5. And then you just solve it like we have the other problems. Now we're going to go on to inequalities. If you look at the top of page 3 in the gray region, it says you can write absolute value inequalities as compound inequalities. The graphs below show 2 absolute value inequalities. So pause the video, look over them, and then come back. Now, I want to give you a little cheat sheet, a little hint. The first inequality is a less than. If you have a less than, you're going to shade inward, because the distance from 0 is getting smaller. If you have a greater than, you're going to shade outward, because the distance is getting farther away from 0. So there's your little hint. So let's do the got it problem on page 83. The absolute value of 2x plus 4 is greater than or equal to 5. Instantly, you see this greater than, you're most likely going to be shading outward because you're getting farther away. So, here's how you do it. You're going to write it down exactly how it's written as one of your inequalities. 2x plus 4 is greater than or equal to 5. There's the first one. The second inequality is exactly what you did with equations. It's going to be 2x plus 4, and it's going to be negative 5. But the other thing you're going to do is flip the inequality. So one of your inequalities is going to be the same as the problem. The other one is flipping the inequality and changing the number to a negative. Now solve these. We subtract 4. 2x is greater than or equal to 1. Divide by 2. X is greater than or equal to 1/2. Subtract 4. 2x is less than or equal to negative 9. Divide by 2. Negative 9/2 or negative 4.5, either one. Now we have to graph this. Now, if we have, let's say, 0 and 1. Now, you're not going to put a 1/2. 1/2 goes between 0 and 1. So, negative 1, negative 2, negative 3, negative 4, negative 5. Now, since these are greater than or equal to, less than or equal to, we are going to have a closed dot at 1/2. We're going to have a closed dot at negative 4.5. Now, if you don't know whether to shade inward or outward, you just look at it and ask yourself, well, it says greater than 1/2. Well, greater than 1/2 is going to go this way. And it says less than negative 4.5, so that means we go this way to the left. Because you are shading outward, this is a OR problem. That's important to note that and to write that down. Now let's do problem number 8 on page 84. The absolute value of 5m minus 9 is greater than or equal to 24. The absolute value is isolated by itself, so we're going to get 5m minus 9 is greater than or equal to 24, and 5m minus 9 is less than or equal to negative 24. Add 9. We're going to get 5m is greater than or equal to 33. Divide by 5. It would be 33/5, or we could write it as 6 3/5. Add 9. That would be negative 15. Divide by 5, negative 3. So if we graph this, negative 3 is here. We'd have a closed dot. 1, 2, 3, 4, 5, 6, 7. 6 3/5 would be about right here. And since we are shading the region greater than 6 3/5 and less than or equal to negative 3, you would shade the region outward because it's greater than 6 3/5 and less than negative 3. Therefore, this is an OR problem. That is your answer, and so is that. Let's now look under the problem 5, the got it on page 84. A food manufacturer makes 32-ounce boxes of pasta. Not every box weighs exactly 32 ounces. The allowable difference from the ideal weight is at most 0.05 of an ounce. Write and solve an absolute value inequality to find the range of allowable weights. Now you could probably figure this out in your head, but here's what we're going to start with. Do we know the actual weight of the pasta box? Now, remember, it's supposed to be 32. But do we know every one that comes out? We don't. So let's say W, since it's the weight. Now we're going to subtract the 32. Now here's the deal. The weight of the box could be over 32 or under 32, but we need to find the difference, whether it be more or less than the actual 32 ounces. That's where you get your absolute value. Because your difference, we don't care if it's negative or positive, it could be either way. It could be a little more than 32, a little less than 32. Now it says the difference can be at most 0.05 or 5/100ths of an ounce, which means you can't go over it. It can be 5/100ths, but it can't go over. That means it has to be less than or equal to 0.05. So now the absolute value is already isolated, so we're going to write W minus 32 is less than or equal to 0.05. And W minus 32 is greater than or equal to negative 0.05. So if we solve these, we add 32, add 32. This weight can be less than or equal to 32.05 ounces. And on this side, we add 32. It could be greater than or equal to 31.95 ounces, or 95/100ths of an ounce. So, if we wrote this, 31.95 is our minimum, 32.05 is our maximum, and it can be less than or equal to, which would be the value of, W, and that's a really bad W, is less than or equal to 32.05.